Hi guys, so welcome back. So previously we were looking at this question, BMAT 2015 question 4, really just reiterating how to use a tree diagram, especially in the cases when you're doing things without replacement. But hopefully guys, by now that has made sense. Now guys, we're going to move on to the next question, which is BMAT 2014 question 24. It says, a test is developed to detect a certain medical condition. The test is not perfect and sometimes gives incorrect results. The behavioral test on 1,000 randomly selected members of the population is shown in the tree diagram where the following notation is used. So C has the condition, and generally C prime, or the prime in general means not C, basically in this case does not have the condition. T tests positive and T dash doesn't test positive or basically tests negative for the condition. And it says three of the branches proportions are shown in the diagram, and it just gives us the numbers we have. And then it says a person is selected at random from these 1,000 people and tests positive for the condition. Now, what's the probability that the person has the condition? So, guys, pause the video in this case, give yourself a minute, and be sure to be back after that minute where we're going to go over the solution. Okay, guys, so welcome back. So, here we want to work out the probability that the person has the condition. So, the probability the person has the condition, but there's a condition to that because the person that we've selected is already positive, they already test positive. So, is the probability they have the condition given they've tested positive, which is denoted by T in this case, right? And remember the formula for the given, which is a really, really important formula for the probability section of BMAT section 2 maths. So this is going to be probability of C and T over the probability of T, right? So the probability of C and T, right? So that's going to be this one and this one, isn't it? That's going to be those two. So remember, and means multiply. So it's going to be 1 out of 100 times 4 out of 5, and then over the probability of t, right? So basically, what we need to find here is how can someone test positive for the condition? How can someone test positive for the condition exactly? So they can either test positive by having the condition and testing positive, basically just the above. So times 4/5. Or remember, or in probability language means plus, or they can not have the conditions of C prime, right? And also, we should actually fill in the remaining branches. This is going to be 99 out of 100, because remember, the branches have to add up to 1, and this is going to be 1 out of 5, and this is going to be 9 out of 10, right? Plus the other way they can test positive if they don't have the condition, so 99 out of 100 times them testing positive, which is going to be 1 out of 10. 1 out of 10, right? Now, we basically need to brush this up. So this is going to be equal to now 4 over 500 in the numerator over 4 out of 500 again, plus it's going to be 99 out of 1,000, right? So 99 out of 1,000. Yep, so 99 out of 1,000. And then what I'm going to do is the 4 out of 500, I'm going to turn that into 8 over 1,000. They are going to be equivalent over 8 over 1,000 plus 99 out of 1,000. And then all of the over 1,000, I can just cancel them out nicely. That's great. So then I'm going to get 8 out of 99 plus 8, which is going to be 107. So 8 out of 107. And therefore, the grand answer, therefore, guys, is going to be E in this case. So I really hope, guys, the understanding of this question makes sense of why I got to this answer, and crucially, the importance of using the given formula, especially in BMAT section 2 maths. So I really hope that has made sense, guys, and I look forward to seeing you in the next video. All right, guys, so previously we were looking at this question, BMAT 2014 question 24, really going over again how we use the given formula in not really, I hope, guys, it wasn't really a complicated sort of context in which it was given in. I hope really, guys, that has made sense, and now you're more versatile in using that given formula in different settings. Now, guys, we're going to move on to the next question, which is BMAT 2013 question 24. This is a bag contains 8 blue and 2 red balls. 3 balls are chosen at random at the same time at random from the bag. This is what is the probability that exactly 2 of the ball are the same color. So, guys, pause the video, give yourself a minute. Be sure to be back after that minute, and then we can go over the solution. Okay, guys, so let's go over this. So we're basically selecting 3 balls, as it says, and we want to work out the probability that exactly 2 of them are the same color, right? So if 2 of them are the same color, you can either have 2 blues and a red, right? Or you can have 2 reds and a blue, right? Those are the only two situations you can have. But then if you think about this red, right, that red can take three positions. It can come at the end, the middle, or the start. So you can have B, R, B, or you can have R, B, B, right? And then similar thing over here, the B can either be the end, middle, or start. Therefore, you can be R, B, R, or you can either be B, R, R, right? So those are your three situations. And then when these are basically permutations, so different ways you can get the same thing. And whenever you get this, guys, all you have to do is work out the probability for one of them. So let's work out the probability for BBR. So the probability for BBR is going to be probability I take a blue on the first one, which is going to be I have 8 at the start out of the 10 balls in total. Probability I got a B next, right? So in the first go, I've already taken one of the blues. So there's only 7 left now. And since I've already taken a ball in the first go, it's going to be out of 9. And then probability I get a red then. So that's going to be 2 because I haven't taken any red at this point. But now it's going to be out of 8 because by this point I've already taken 2 balls, right? And then what you do here, guys, is that's going to be 7 times 8 is 48, 56. Times that by the 2 is going to be 112, right? Over 9 times 8 is going to be 72 times 10. 72 times 720, isn't it? Yeah, so that's going to be 720. But then remember, guys, you have to times this by 3. So this thing times it by 3 because there's 3 ways of getting this, right? So it's going to be 7, 14, 28, 56, 112, yeah, and then triple that. It's going to be 336. So 336 over 720. Now we do the same thing for below. So probability of getting a R in the first go is going to be 2 out of 10. Then the next is going to be 1 out of 9 because we've already taken a ball from the first go and that was a red one. So there's only one left now and it's out of 9 balls because I've already taken one. Times the blue, which is going to be now 8 because I haven't touched them yet, but it's going to be out of 8. And that makes sense, isn't it? Because it's basically saying that probability of getting a blue in the last go is 1, so it's certain, which is true because there's only 2 red balls and I've taken them at the start. Therefore, the only balls remaining in the bag at the end would be a blue one. So I'm definitely getting a blue. Therefore, basically what we get left with here, guys, then is that's just 1, so you can cancel that out, is going to be 2 out of 90. And again, 3 ways of getting that. So times that by 3. And that's going to give me 6 out of 90, right? And then basically we just need to add those together. So let's see if we can simplify this, guys. We can simplify that to 150 plus 18, 168 over 360. We can simplify that further, I guess, into 84 out of 180 and further into 42 out of 90, right? And now that's a good place now because the way we can get 2 balls of the same color is either this one or this one. So now is a good place to add them because they have the same denominator. We're going to get 48 out of 90. Simplify that further, 24 out of 45. Can we simplify that further? 6, the 6 go into it. 3, that's it. 3 goes into it. So then 24 divided by 3 is going to be 8, and that's going to be out of 15 because 45 divided by 3 is 15. And therefore, the grand answer that gives us, guys, is C. So I really hope, guys, that has made sense. A bit of arithmetic there, but hopefully that hasn't caused too much problems. And hopefully this was a good question to revise some content. But guys, see you in the next video as always, and good luck with everything. All right, guys. So in the previous question, BMAT 2013, question 24, we were looking at this question, which was really good because it we came across the idea of permutations and how we basically deal with them in the context of the BMAT and in any other exam, to be honest. But now, guys, let's move on to the next question, which is BMAT 2012, question 20. So it says, in a fair ground game, there are 2 bags, each of which contains 4 colored balls. There are a total of 4 red, 3 yellows, and 1 blue. The player chooses one of the bags and removes 2 balls without replacing them. If the 2 balls are the same color, the player wins. If the players equally like to choose either bag and the balls are arranged to give the smallest possible probability that the player wins. What's the probability that the player wins? So guys, pause the video, give yourself a minute, be sure to be back after that minute, and then we can go through the solutions. Okay, guys, so what do we have here? So we have basically 8 balls in total. So we have 4 red, 3 yellow, and 1 blue. And these are basically partitioned into 2 bags, right? And the aim of this game, guys, as they say over here, is essentially the player selects a bag. So let's just say bag A or bag B. and then from the selected bag, they select 2 balls, and if the 2 balls are the same color, they win. But we want to minimize the probability of that happening. So, for example, obviously, it'll be stupid if we put all 4 of the red balls in one bag, because that would mean they definitely win, right? So the 4 reds, it would actually be best, lowest chance for them winning, basically, if we partition them equally. So you have 2 reds here and 2 reds here. Because if you have 3 reds in one of them, there's a high chance you can win from that bag, because there's a high chance you'll get 2 reds, if that makes sense. Okay, and then the 3 yellows, obviously you can either do a 2-1 split or a 3, well, actually that's the only thing you can do, isn't it? A 2-1 split, because you can't put 3 into either of the bags, because that would exceed the 4 bags which is allowed, 4 balls which are allowed in each bag. So I'll go for a 2-1 split. So let's do Y, Y, and Y there, and then obviously the last one, the blue one, would go here, right? So let's do this. So let's see what's the probability that the player would win from bag A, right? So the way the player can win from bag A is if they get 2 reds, right? So probability of a red and then a red, which is going to be so probability of getting a red in the first go is going to be 2 out of 4, basically half, times the probability of getting red in the second time is going to be 1 out of 3, because you've already taken 1 red ball from the first go, so you basically only have 1 left now, and it's out of 3 balls in total then. So that's going to give you 2 out of 12. Or in this bag, you can actually also win by getting a yellow and a yellow. So your probability of yellow and a yellow, right? And then that's basically going to be the same thing, isn't it? So red and yellow, probably to get a red in the first, yellow in the first goal is going to be 2 out of 4, and it's going to be 1/3 in the second goal. So that's basically the same thing. So no point of wasting your time, guys. Remember, time is of the essence in BMAT section 2, right? So then in total, if we add these two together, you're going to get 4 out of 12 as the total probability of winning from bag A. And then what about bag B? Bag B can only win in one way, which is red and a red. So red and a red. And again, that's basically the same as 2 out of 12, isn't it? Because probability you're going to get red in the first one is going to be 2 out of 4. And then the second goal is going to be 1 out of 3, as before, right? But then you have to think about this. So there's 2 ways of winning. So the way you can win is selecting bag A, which you have a 1 in 2 chance of doing, isn't it? So probability of winning with A, right? So that would involve you selecting bag A in the first place, which is you equally there's an equal chance yes, it's equally likely to choose either bag, right? So the way you can win with bag A is that you have to select bag A first. So there's a half probability you can select bag A, and then once you've selected bag A, you have to win using bag A. So that's going to be 4 out of 12. And similar thing here, probability of win with B, right? That's going to be probability of you selecting B, which is going to be half, right? Times the probability once you have B winning, which is going to be 2 out of 12, right? And if you just brush this up, you're going to get 4 out of 24 here, and here you're going to get 2 out of 24. Add them up, you're going to get 6 out of 24, which is exactly a quarter. So therefore, guys, the answer you should get in this question is B. So if you want, guys, you can also think of this as a tree diagram. So the first thing you do is you select the bag. So you select either bag A or bag B. And then the next thing you can do is you can either take a W or take a L, right? So you can either take a W or you can take a L, right? If you think of it in that way, that would also help you to maneuver around the question. But I hope, guys, either way that has made sense. And as always, we look forward to seeing you in the next video. All right, guys, so previously we were looking at this question, which was a game where you select a bag, and therefore the aim of the game was essentially to select 2 balls of the same color. This was a really good question in terms of applying your knowledge to different concepts, and the more of these you do, guys, the better at them you would get. So let's, without further ado, guys, move on to the next question, which is BMAT 2011, question 24. This is, I have 2 6-sided dice, each with numbers 1 to 6. One of them is fair, but the other is not. It will land on 1 to 5 with equal probability, but lands on 6 with a different probability. It says, when I roll a dice, the probability that I will get 12 is 1 out of 8. It says, what's the probability that I get a total of 2 when I roll the dice? So guys, pause the video, give yourself a minute, be sure to be back after that minute, and then we can go over the solution. Okay, guys, so what we know here then is that one of the dice is fair, so the probability that will land on any of the numbers from 1 to 6 is going to be 1 out of 6, right? But the confusion lies in the other dice, which is unfair, right? So in the dice then, let's just say X, which is the number you can get, you can either get obviously 1, 2, 3, 4, 5, and 6. And then what's the probability that what we get is that number above, right? So probability x equals x, right? So we know that it says it lands on 1 to 5 with equal probability. So we can just call that, for example, A, right? So A, but it lands on 6 with a different probability. We can call that B, right? And we have another crucial bit of information, which is the probability that you can get a 12 is 1 out of 18, right? So the only way you can get a 12 in rolling a dice is if you get a 6 and a 6. So probability you get a 6 and a 6. So a 6 on a fair one would be 1 out of 6. And so times and 6 on an unfair one, which is going to be B. And this should equal to 1 out of 8. Therefore, this means that B must be a third. No, not a, yeah, so this should be 1 out of 18, yeah. So it should be a third. Because then if you do 1 over 6 times 1 over 3, 6 and 3 would give you 18. So B is a third now, we know that. So remember now, guys, probabilities have to add up to 1. So that must mean all of these guys then must be equal to 2/3, right? So then 2/3 must equal to 5A, and therefore A must be 2 out of 15, right? So we know A is 2 out of 15 now. So now it says what's the probability that we can get a 2? And the only way you can get a 2 is if you get a 1 and a 1. So it's going to be 2 out of, so getting a 1 on the fair dice is going to be 1 out of 6, and a 1 on the unfair dice is going to be A, which is 2 out of 15. And if you times this together, you can cancel that out to 1, you can cancel that out to 3, and therefore what you should get, guys, is 1 out of 45. And this lands you then on the grand answer of B. So this is a really good question again, guys, to get you thinking, and I really hope my explanation has made a lot of sense. So hi guys, welcome back. So previously we were looking at BMAT 2011 question 24. This was a really good question which involved a bit of algebra, involved a bit of thinking, I hope, and hopefully you managed, guys, to land the correct answer. But even if not, guys, hopefully you managed to learn from my explanation. Now, guys, we're going to move on to the next one, which is BMAT 2010. This is a children's game is played on a square grid starting in the center. The players spin 2 spinners to decide how to move their counters. The first spinner decides the direction, and the second spinner decides the distance. What are the chances that after 2 moves, a player is exactly back where they started? Okay, so guys, pause the video, give yourself a minute. Be sure to be back after that minute, and then we will go over the solution. Okay, guys, so welcome back. So let's go through this. So basically, what we want to do is after 2 goes, they want to be back at where they originally were. So one example of how that can happen, guys, is if you get, so probability of if you get a left one, but then in the next goal, what you must get then is so you must get a left one in the first goal, and then you must get a right one in the second goal, right? And then obviously this can happen all the way until you get left 4 and right 4. So you can get right 2, left 2, right 2, left 3, right 3, and lastly left 4, right 4. And obviously this happens also with the ups and downs. So you can get up 1, but then the next one you must get down 1, and this can happen all the way until you get up 4 and down 4, right? So we need to work out what these probabilities are, right? So probability that you get a left and a 1 is going to be 1 out of 4 times 1 out of 4, which is going to be 1 out of 16, isn't it? Right? Because this is fair, so there's equal proportions of all of them in both spinners, right? And probability you get a right and a 1 is basically the same thing, 1 out of 16, right? And we want a left one and we want a right one, therefore we have to times these two together, right? So you basically get 1 over 16 squared, right? So you just keep it as that. And if you do it for all of them, guys, you get the same value. You can try it out because all of them is going to be 1 out of 16. So for example, left 2 is going to be 1 out of 4 times 1 out of 4, 1 over 16. Right 2 is going to be 1 out of 4 times 1 out of 4, 1 out of 16. And then when you times it together, you can get 1 out of 16 squared. So you get 1 out of 16 squared, 1 out of 16 squared, and just get 1 out of 16 squared. And also for all of these ones, guys, you're going to get 1 out of 16 squared, right? But now you have to also think about another thing, guys, is that you can basically get a left one. So here we said, for example, you can get left one and then right one, but you can get that thing in reverse, and that would have the same effect. So going right one and then left one, that would still bring you back to the same position. So then all of those ones, you have to times them by 2, right? So if you times all of these by 2, all of these now, so all of them will be basically 2 out of 16 squared, right? And same thing over here, all of these ones now would be 2 out of 16 squared, right? And we have 4 there and we have 4 there. So therefore, in total, this will be 8 out of 16 squares. Because remember, you can have situation 1, or situation 2, or situation 3, or situation 4. So or, remember, means add. Same thing over here. So this is going to get transformed then into 8 out of 16 squared as well, right? And then then you can have this situation or this situation. So add those two together, which is going to give you 16 over 16 squared, and divide top and bottom by 16, so you get 1 out of 16. And therefore, this lands you guys onto C, which is the correct answer in this case. So I really hope, guys, that has made sense. This was actually a good question to actually make you think about the situation. But either way, guys, hopefully that was really helpful, and I look forward to seeing you in the next video. All right, guys, so welcome back. So previously, we were looking at BMAT 2010 question 8, which was this game, which was a really good question because it makes you think about what are the different combinations and really give you shortcuts of how to deal with these somewhat a little more difficult situations. But now, guys, we move on to the next question, which is BMAT 2009 question 4. This is a bag contains X red balls, Y blue balls, and Z yellow balls. One ball is selected at random and taken out. One ball at random is taken out and replaced. A second ball at random is taken out and replaced. If the balls are identical in all respects, except color, and are well mixed, what's the probability that the first ball was red and the second ball was yellow? So, guys, pause the video, give yourself a minute. Be sure to be back after that minute, and then we can go through the solution. Okay, guys, so we want to work out the probability that the first was a red and the second was a blue. So the probability the first was a red is going to be X red. So how many red balls there are over the number of balls in total? So X, Y, and Z. And you want the second one to be blue, right? So remember, the ball was replaced after the first goal. So since that's the case, then basically the total is, imagine you're basically starting all over again, like you're selecting a ball as if it were from the first goal. So it'll be the number of blue balls, Y, over the number of total balls, which will be unaltered because you've replaced the ball. So you've got X plus Y plus Z, and you want this and that, so you times them. So you get XY over X plus Y plus Z all squared. So that's going to be, guys, C. In this case, is going to be correct answer. So hopefully, guys, that has made sense. And as always, really look forward to seeing you in the next video.